Hello, okay. Still on module 4, this time unit 2, okay. So in your unit 1, we tackled your application of definite integral in evaluating plane areas. Okay, so how about now? We will now be getting the centroid. Okay, so if you'll try to recall your centroid, if you say centroid that is, okay, so in physics, okay, let's say this is the object, okay, let's say that is the area. And if you are talking here of centroid is the point wherein if you will consider that one, it will be balanced all throughout the direction of the object being considered or the area. Okay, so that is centroid. That is what we are trying to find in this unit or in this application of definite integral. Okay, centroids of plane area. Okay, so in this unit, these are your learning outcomes. First is to understand what is centroid and how is it located using the concept of definite integral, and to calculate centroid using horizontal element, and of course centroid using vertical element. So what is centroid? Okay, so centroid, okay, in this figure, again, as I'm saying, if this is the area, centroid is the point on the area wherein if you try to consider that, it will be balanced all throughout the direction. Okay, so we commonly denote that one as x bar y bar, the coordinates of your centroid. Okay, x bar y bar, these are the coordinates of centroid. So again, we call that one, sometimes call that one as the center of gravity or center of mass. Okay, considering the area to have a homogeneous type, or that is a homogeneous area. If we say homogeneous, okay, as I'm saying again a while ago, for example, again, this eraser, if you are considering, let's say, a solid, for that to be true, that the centroid is where everything is balanced or every direction is balanced, that your material or the material you are considering should be homogeneous. If you say homogeneous, the type of material in this one is the same. And of course, if you say homogeneous, let's say if we are talking here of solid, that should be the same thickness all throughout. Okay, so that it is true that the centroid is actually the center of gravity or center of mass. Okay, so however, we are still on plane area, so we are talking only about the area itself. Later on, if we will reach your centroid of volume, then that's it. It should be the same thickness. Okay, so let's try to talk about first moment of area. If we say first moment of area, this is the product of the area with its distance, with the distance of the area to the reference point. However, since of course we are talking about the area, which side or which part of the area is that distance located? That distance is located to the centroid. That is the first moment of area. Okay, that is the use of your centroid. Later on, if you will go to mechanics and so on and so forth, you will be using the centroid. Okay, you will be using the centroid for the moment, especially if you are on design subjects already. Okay, so again, first moment of area. If you say moment, all we need to do is rotate or multiply the distance of a certain object from its centroid to whatever reference, if that's a point or a line, that is a moment. So first moment of area, we are going to multiply it once. Okay, which is in this topic, the axis will serve as the reference line. Okay, so our reference line here, where we will try to get the distance to be multiplied, is the x and y axis. Okay, so the moment of the total area, okay, the moment, again, that is what I'm saying, the moment is the product of the area and the distance, is equal to the summation of moments of its differential area. Okay, so the moment, the product of the total area and the distance of the centroid is the same if we will try to divide the area part by part or small into small pieces. Okay, so again, instead of considering the whole, we will considering differential parts or these strips, the horizontal element or the vertical element. And if you are considering the centroid of the element and then getting the moment of that, do that one in all of the elements within the area. That is the same if you will summate all that moment of elements of each element. that should be equal to the moment of the total of the whole. Okay. So again, if these are your elements, consider all the elements, get the centroid of the elements, get the moment of that with respect to a reference line. If you will submit that one, that should be the same as the moment of the total, okay, the total area to the reference line. Okay, so that is our concept here. Therefore, the centroidal distance L to any reference is given by the formula. Okay, so again, let's try to write that as L. Okay, that is the centroidal distance. But later on, if we are now on the strip, we will be using x bar, y bar, or if you are, you can actually use x bar, y bar. This is only for the analysis. This is only for the analysis of what is centroid. Okay, so as what I'm saying, the moment of the total A. So again, the moment of the total area, that is A. So moment is area times the centroid, let's say that is L, is equal to the summation of the moments of differential areas. So let's say this is the strip. Okay, for example, it could be horizontal or vertical, but let's just say that is dA. And then get the moment of that. So the moment of that is dA, the area of the strip is dA times the centroid. Let's put there sub C. Okay, centroid of the element or the strip. Okay, so now do that one in all of the strips all throughout this area, and then submit that one. That should be the same on the total area. Therefore, okay, that is the case. If you want, therefore, if you want the centroid of the total, then this is just algebra. You will evaluate the summation of this by definite integral, and then cross multiply below, so that that will be divided by the total area. You will now have the centroidal distance, whatever reference. Let's say you want to get that from x, you want to get that from y, or let's say you want to get that from other references, points, or line. Okay, so that is our concept for first moment of area. That is where we derive how we end up with this centroidal distance. Okay. By the way, x bar and y bar. Okay, if we are talking about x bar and y bar, x bar is the centroidal distance horizontally. Okay, again, since I said that x bar, y bar is the coordinate of the centroid, it means coordinate that is referred to the origin, from the origin. So y bar, it means that is the y coordinate from 0, and then x coordinate from 0. Okay, so using horizontal element, let's try to derive our formula for this. Okay, this is the general first moment concept. Okay, first moment of area. So again, as I've said, what if we will consider here horizontal element? This is your dA. So your dA will be, what is that? Okay, your dA will be x times dy. So your centroid of that, let's say that is x sub c. That is not the centroid of the total. The centroid of the total, that is your x bar and y bar. Okay, your element, since that is just the element, let's say x sub c and then y sub c. Okay, centroid of the element. So the again, that is from, I explained how this is derived. So instead of using that one again or going to the summation is equal to the total, we will use this one. So that is the centroidal distance of the total area. Okay, L is the centroidal distance of the total area. So let's just focus first on the centroid distance from or horizontal centroid distance, or that is the x bar. Okay, so horizontally we will try to moment your area or your differential areas with respect to y-axis, or x equals 0. So centroidal distance, that is the unknown x bar, is equal to the integral. Okay, summate now by using definite integral the moments of your strip. So area of the strip times the centroidal distance of the strip, which is your x sub c. Area of the strip is d sub a, that is your small area. So what is that? That is x times dy, since I am using horizontal strip. And then of course divide that by the total area. That is coming from this other side, isn't it? That is the total area, and then the centroid of the total area. So that will go down, since what we are after is the centroid. Okay, how do we evaluate area is, of course, that is our unit 1, getting plane areas. So you know how to evaluate that A. So again, all you need to worry is maybe you can forget first about your A, since you already solved that one. But actually solving your A will actually prepare you for the formula also of centroid here, your xc times dA, since actually that is there is just a slight difference of getting the area and getting the centroid. So if you evaluated the area, you already prepared your equation almost as for the centroid. Okay, so once you have the area, okay, just leave it there below, or later on you can divide that once you will go to the final answer. So first, our problem here is to integrate or to summate the moments of each strip. So again, that is your centroid is x sub c, and the area of that is x dy, since I am using horizontal strip. So again, what is x dy? I will change that x by x right, x left, so that will just be purely equation of y. And of course, that x sub c, I need to change that one in terms of y also, so that everything will be a function of y, so that we can integrate. We are integrating a function of y. So again, x there is x right, x left, just like a while ago, just like in area. Here x sub c, okay, x sub c is the centroid. Okay, so how do we get that one? According to this one, to what I wrote here, xr plus xl over 2. What is xr? We summated the right and left and we divided by 2. That is actually the average. Why? Because again, xr is, if you will try to go to the concept of area, xr is the right side of the element, or the rightmost side of the element from the origin, and the xl is the leftmost side of the element from the origin, isn't it? So that distance xr is to this point here, and the xl is to the point there from the origin. So what I need is x sub c. And what is centroid? Since that is just a strip, so it will actually serve just like a line. What is the centroid? For you to balance a line that is exactly at the middle, isn't it? So therefore, the centroid of that strip, since we are talking here of x sub c, that is the centroid of strip, is just the half, or that is just the middle of the strip. So how will I get the centroid of that? That is again from the origin. So again, from this rightmost, that is x sub r, from this leftmost, that is x sub l. So for me to get the between, that is actually the average. So x right, add this bigger distance, plus the xl, smaller distance, divided by 2, you will get the distance of the between point, or the centroid of that strip. So that is your x sub c. Okay, so now all we need to do is, okay, substitute your x left, okay, I mean xc and x. X is xr minus xl, and then xc is xr plus xl over 2. So how does that happen? Okay, let me show you, since I did not write it there. Let me show you here in the blackboard. Again, originally, what is our limit? Since we are using horizontal, so we should get the limit on the y-axis, since we will be moving vertical. So c to d, and then again, integral, yan na ito, x sub c x dy. And of course, your 8. So let me just separate here your 1 over your divisor 8. That is 1 over 8. So x sub c is x r minus x l. And you have the x, I'm sorry, that is interchange. The xc is the average. Xc is xr plus xl all over 2. And then of course, your x there is your x right minus x left. And that is dy. And of course, your integration c to d, and you have there 1 over 8. Then actually you can bring outside your 1/2, since that is just a constant that is not affected by integration, so that will become 1 over 2a. Or again, the a will be divided below. So that is in our formula. The a could be below. Or you can just forget first about a. Okay, or let's say, let's forget first about a, that will be below. So 1/2 integral from c to d. Okay, I will expand this one. Okay, 1/2 is already there. So you are multiplying this binomial, a sum and difference of identical terms. So xr is xr squared. And then xr negative xl is negative xr xl. And then this is positive xr xl. So if I will add, this will cancel. And then finally, xl positive, xl negative will be negative xl squared. And then of course dy. So all we need to do is, once you know your xr, get the square of that. The x right, get the square of that, plug in. If you know your xl, get the square of that and then plug in. That should be minus. Okay? That should be minus. So now, all I need to do is integrate again and plug in your xr squared, xl squared, pure equation of y, integrate that one, multiply by 1/2 and divide that one by the total area that you solve using plane areas. Then you will have your x bar. Okay, that is for x bar. Okay, that is for x bar. How about this y bar here? Okay, how about this y bar here? So how did we end up? Since again, a centroid should have a complete x and y coordinate. So that is how we will evaluate your x coordinate. So this is our formula for that. Okay, how about your y bar? The same thing, the same concept. So instead of getting the moment with respect to horizontal or horizontally, now we will be having the moment vertically. So your distance is now vertical. So the same, we are still focusing on the horizontal strip since that is what I assumed. Okay, so what will I do is the same thing. Y bar, that is the centroid of the total with respect to vertical or vertical centroid, or that's the y bar, is the summation of the centroid or the moment of the strip divided by the total. So again, our centroid now is y bar since we are referring to vertical distance. So the centroid of the strip there is now your y sub c. Still, we are referring to the centroids of the object and the strip. So now, what changed there is only your y sub c, and of course, okay, our limit is still the same since we are still on horizontal. So we are summating going up. So your limit is still from C to D. So again, all I need to do is change. Your x is still the same, xr, xl, but your y sub c is what? Okay, y sub c is, you do not need to change your y sub c. You do not need to change your y sub c. You do not need to change that one. Why? Because y sub c, you can say that that is y, since again, if that is y, okay, since this is a strip, the location of the strip is exactly, since that is considered to be just a straight line, very, very thin. So the location of that strip, the center of that strip, is actually just the distance from the origin. So therefore, what is a distance from the origin? That is y. Okay, therefore your y sub c here is just y. So all I need to do is plug in y. I do not need to be changing that y upper, y lower, because that is already a variable y. And what we need is a variable y. So that's it. So your y here, okay, that is your y. And dy, all we need to do is change your x into xr, xl. And then change that xr whatever value of the rightmost side, and then xl whatever the value of the leftmost side. So these are our formulas for the centroids, x bar and y bar, using horizontal element. Okay, how about vertical? The same thing, all we need to do is assume a vertical element, so the same. However, this time, if you want the x bar, that is still x sub c, and your dA will just change to y times dx. Okay, and your limit of course will change since we are now moving horizontally, summating all the vertical going from left to right. So we will be getting the limit from x-axis, so a to b. So that is my limit. A is still the total area. So again, if you can evaluate the centroid by horizontal element, or you can also evaluate that by vertical element. So it's up to you. There are some cases wherein the other one is simpler. Okay. So again, in our figure, x sub c there is what? Okay, just like a while ago in here, y sub c is just the distance of that centroid of the exact strip from the origin, so that is y. In here, in vertical element, that x sub c is, since the strip is now standing, that is just a very, very thin, so that centroid is the same as the location of your strip, so that is just the distance to the point, so that you can write that as actually as x. Okay, Why is it that I cannot write your y sub c as y or only? Because of course, I already have their y. Same thing here. Why is it that I cannot just write that x sub c here as x? Since I already have that x here. That is our variable x. Okay? So in here, I did not have yet that y. So I can write yc as y. In here, your y is already there. So I cannot write yc as y. So how will I end up with y sub c? That is now your vertical element, y upper minus y lower. Okay? Substitute that there. And then x sub c is x. X sub c is x. I explained that one a while ago. And then, okay, the same things. X, you do not need to change that since that is what we need is variable x. All you need to do is change the y upper, y lower, purely equations of x, integrate. And then, of course, whatever the value there divided by the total area that you first evaluated. And then how to get your y sub c? Okay, how to get your y sub c? So the same thing, okay, all we need to do is consider a vertical here. So y bar, not y sub c. So y bar is the total, and then y sub c is the centroid of the element. Then the area is y dx, just like this one, y times dx, and then of course divided by the area. Okay, so again, y sub c. Y sub c is again, that is the average. Okay, that is the y sub c is the average, isn't it? Y sub c is the average, since again I cannot write that as y. Okay, I cannot write this one as y, your y sub c as y, since that is already there. So that is again the average of your y upper, y lower for me to get the distance here. And then your y is still y upper, y lower. Okay, substitute there. Just like my explanation a while ago here, expand that one, your 1/2 will be factored outside. That will be y upper squared minus y lower squared. Okay, so that is your formula for y bar and x bar using vertical element. Okay, so let's have an example, the same example on getting the area. Okay, so let's try to find out the centroid of this. Actually, by what we call this one, by observation, you can see that the centroid is located on the y-axis. Why? Because as I'm saying on the discussion of the area of this, that it is symmetrical with respect to y-axis. So it means that the balancing point of that area is somewhere there on the y-axis, somewhere here on the y-axis. All we need to find actually is to find the location of that vertically. Since horizontally we know that that is at the origin, 0. But okay, let's still try to prove that one. So let's say we do not know where that is, that x bar. Okay, let's say we do not know that one. So I am using a vertical strip. Let's try to make use first of a vertical strip. Later on, maybe we will be using now horizontal so that you will also see. Okay, so for the meantime, vertical strip, but actually you can solve this one using a horizontal strip. So it's up to you. You can do that one as a way of practice also. Okay, so again, what is our formula? Okay, this is the general formula. All you need to do is cross multiply a below, but I do not be writing it so that it will not be complicated. So I will not be writing it that way. So a is still there on the other side. Okay, all I need to do later on is bring that down. So first, establish or evaluate the area of this, which is actually we already evaluated that one previously on the example. That is previously, that is 32 over 3. 32 over 3, that is the total area previously. Okay. Okay, sige. So that is 32 over 3. That's when I cross multiplied that a. But first, let's try to evaluate this side, this right side. So again, your dA will just y dx since I am using a vertical strip, x sub c since we are finding first your x bar. Okay, so your y here is y upper, y lower. Your x sub c there is x. Okay, your x sub c is x. Since I did not yet use this x, but I cannot write there I cannot, of course, just leave their y since that should be a variable in terms of x. Okay, so now what is the y upper? Look at the, okay, so what will I do is plug in that y upper, y lower. Okay, y upper minus y lower, and then x sub c is the x here. And then y upper, y lower. So what is the y upper? Go there, what is the y upper? What that is the y of this equation. So actually it is just 4 minus x squared. So y upper minus y lower. Y lower is the x-axis to 0. So I do not need to be writing that minus 0. Even if you will write that, that is still useless. So that is now our the total y upper, y lower, but your y lower is 0. Okay, so that is the equation. So now it is now purely equation of x. So if you want, you can take it. You cannot take this one as a product rule since we do not have product rule, isn't it, in integration? So what will I do is simplify by multiplying inside. So that is 4x and that is x cubed. So integrate power rule. This will be 2x squared minus x4 over 4. Apply your limit. So upper limit is positive 4 minus apply your lower limit is still positive 4. So eventually that is 4 minus 4 is 0. Divide it. Even if we know the total area 32 over 3, divide that one, that 0 by 32 over 3 is still 0. Which is true because of, again, by observation, by investigation, it's like what I've said a while ago, that is symmetrical with respect to y, so the centroid of that should be located in the middle, which is the y-axis. So we know that that is here in the y-axis. Now, what we need is, again, centroid that should be complete x bar, y bar. Okay? So now, let's find the y bar. What I need to do again is make use of the total area summation of the strip. So again, I will not be writing a below so that will not be complicated. I will first be putting it here. So y sub c times dA, since we are now we want to get your y bar, so that should be y sub c. So your dA will just become y times dx, and then your y is what? Okay, what is now your y? Y is, again, I cannot use y sub c as y alone. Why? Y is already there. So what will I do is I will get the average of your y, which is, okay, what is the average of y? That is y upper minus y lower divided by 2. Y upper plus y lower divided by 2. And then again, your y will be y upper minus y lower. Okay. So what is the y upper again? That is your 4 minus x squared minus 0. Why? Because the x sub l, the y sub l is the x-axis or 0. And then, therefore, that is as simple as this. Do not forget to square that one. Since again, what isn't it? You'll try to go here. That should be, we are using vertical. Y upper squared minus y lower squared. However, we do not have y lower. So that is 0. So we will only be integrating y upper squared. If that there is a y lower, then all you need to do is minus that y lower and then simplify before integrating. But since we do not have y lower, that is just y upper squared. We will multiply this one, isn't it? Okay, so now we are left with this. Integrate. Again, there is a 1/2 there outside. In here, there is no 1/2, of course, because we did not use the average. Okay, so again, integrate, but first expand, since you cannot use here power rule, since if this is your u, that should have be 2x dx, negative 2x dx, which is you cannot input their x as a balancing factor. So all I need to do is, my choice here is to expand, so this is the expansion, so now I can integrate. Okay, so integrate 16x, that will be x 3 over 3, that is x 5 over 5, and then upper limit is 2, and then lower limit is negative 2. Substitute upper limit, there is a 1/2, do not forget there is a 1/2 outside. Upper limit, that will give us positive 256 over 15. And then lower limit, negative 2, will give us a negative 256 over 15. So negative and minus will become plus. And then do not forget that should be multiplied by 2. So that will be 256 over 15. And again, that is not our answer, because on the other side, you still have that a. What we are after is y bar. So we evaluated again by area, that the area of that is 32 over 3. So divide, cross multiply a. You will have your y bar as 8 over 5 or 1.6. Okay, that is 1.6. So again, it means that this area, if I want to get the point where every direction is balanced, that should be located at, okay, what is our x bar? 0, and y bar is 1.6. So located at the y-axis and 1.6, somewhere there. Okay, somewhere there. So if you will hold, let's say that is a plate, if you will hold at that point, it means that will not fall because that is balanced in all directions. Okay, so that is centroid. Using what we use here is vertical element. And again, I showed you how we derive the formulas for y bar and x bar using vertical and horizontal. Okay, let's have one more example, your example number 2. Okay, but this time let's try x bar so that you will see also. I mean x bar. We will try horizontal element. Okay, so horizontal element, I will draw the horizontal. What will be my dimension? X and dy. Okay, so x and dy. So x bar. So x bar times the total area. We solved already the total area, but in your case, if I will give you an activity, you do not know yet the area. So first is establish the area. Solve the area first before solving the centroid. You cannot end up with a centroid without the total area. So again, since we already solved that one on the previous unit, then I do not need to show you that one. All I need to do is go back to the video. So again, the area of that is 9/2 or 4.5 in the previous unit. Okay. So again, integral here is integral of, since that is x bar, that should be x sub c times the differential area. And then that is horizontal, so x times dy. Okay, so your x sub c is, what is the x sub c? That is, again, I cannot use x sub c as x, so I will be getting the average of x right, x left. And then your x there, I need to change that in terms of y, so x is x right, x left. Okay, then now x right, x left. Okay, if you will multiply this one again, this xc and x and x sub c, you will end up with xr squared minus xl squared, isn't it? This one. If you will multiply the average and the difference of these two binomial, identical binomial, sum and difference, that will end up xr squared, xl squared. A while ago, we multiplied this one in the first example, this one, the average and the difference. However, again, your y sub l is 0. That's why we have a simple integration here. But for number 2, okay, let's see. Okay, so your y upper, I mean your x sub c, I mean your x sub c and xc is xr squared, xl squared. So xr, what is your xr? Is this red, the x of that red. So I have your x equals y raised to 1/2. I will rearrange. So since actually, if you try to look at this, y is separated. So maybe the best choice here is vertical. But for us to have for us to have a simpler solution, I mean for us to have another solution using a horizontal element, let's solve it as horizontal. You can try it by vertical, since again, by merely looking, this is how you will decide. How will you know which one is easier? Look at the equations itself. If y is separated, then what you will be using is what we call this one. If y is separated, what we will be using is vertical strip, so that your differential area will be y times dx. Your y, our y upper, y lower will just be the separated y itself. We do not need to rearrange the equation. Okay, so that is how you will know which one is simpler. Okay, however, let's focus. Let's use here horizontal strip. Okay, so y to the right is the y of that. Rearrange, I mean xr is the x of the red. Rearrange that one, that is your y raised to 1/2. Plug it in your xr squared. That will be cancelled. So that will just plainly y. Minus xl squared, okay, again, and 1/2 is factored outside it. Xl squared. So what is your xl? That is the x of this line. So rearrange that one. X of this line is y over 3. Square that one is y squared over 9. So now, this is our integration. Integrate this one. Don't forget that there is a 1/2. So I will carry that one. power rule, y squared over 2, y raised to 3 over 9 times 3, which is 27. Upper limit is 9, okay? We are moving upwards, summating a horizontal going up. So from 0 to 9. So 0 to 9, upper limit is 9, substitute, that is 27 over 2. Lower limit is 0, substitute, that is 0. Do not forget again, there is a 1 half, so multiply 27 over 4. Or in decimal, that is 1.5. Sorry. 27 over 4, that is not the centroid yet. We need to divide it by a. So again, as I've said, we solved this one before. The area is 9 halves. Okay, you can go back to our discussion on that. The area is 1 half. So simplifying this fraction, that is 3 halves or 1.5. So that should be located somewhere there at 1.5. So maybe somewhere there. Okay, somewhere there at 1.5. And then we need to get your y bar. So again, I will just make that y bar, and that will be y sub c. The dA should still be x times dy. Okay, your y sub c there. Okay, your y sub c did not use y, so y sub c is equal to y. Your x, okay, your x is what? What is our x here? That is the x right minus x left. So what is the x right again? That is your y minus 1 half. X left is y minus 3 over 3, I mean. Then y sub c is y, so multiply inside so that we can integrate. That is y 1 half plus 1. Y times y 1 half, the exponent will add. So 1 plus 1 half is 3 halves. And this will be y squared over 3. Integrate by power rule. 5 halves over 5 halves, so 2 will flip on top. Y3 over 3 times 3 is 9. Substitute your upper limit 9, that will give us 81 over 5. Lower limit 0 is still 0. Do not forget again that that is still x bar times a. You need to divide it by a, which is 9 halves. So 81 over 5 divided by 9 halves is 18 over 5, which is in decimal 3.6. So what does that mean? Your centroid is located at 1.5. If this is 1, that is 1.5. And then 3.6, so 2, 3, somewhere there. So my assumption here might be correct. So again, if I will hold at this point, it means that will be balanced all throughout the area. If that is a plate, if that's a plate in that shape, I can hold at that point, and that will be balanced. That will not fall. Okay. Okay, so that is using the horizontal. As I've said, okay, you can use vertical strip. So let's, okay, since I already showed you here, so let me discuss that one. Okay, so this is another solution of number 2 using vertical strip. So what will just change there is just your dA will just become y times dx. Okay, that is the only difference. X bar, so that is xc. So your dA will just be y dx. Your xc is what? Okay, what is your xc? That is equal to x, since I did not yet use x. And then your y there is y upper, y lower. Okay, y upper, y lower. So x sub c is x, y upper is, okay, that is the good thing. We do not need to rearrange since y is already separated. So y upper is the line, that is 3x. Y lower is the curve, the red curve, so x squared. Multiply x inside, and then integrate, that is 3x squared. So x3, there is a 3 there, and x3 over 3, so 3 cancels x3. Minus x raised to 4 over 4. Okay, your upper limit there, we are moving horizontally, summating a vertical strip, 0 to 3. So upper is 3, lower is 0. Substitute your upper will be 27 over 4. Substitute your lower will be 0. So 27 over 4 divided by a, 9 halves. That will be 3 halves. Okay, so still 1.5. That is our x bar a while ago, isn't it? Yes, 1.5. How about the y bar using this vertical strip? So the same. Y bar, that will just become y sub c. Your dA will just become y times dx. And then, of course, what is your y sub c? Y sub c is actually the average of y upper minus y lower. You cannot see that it's y. Why? Because, of course, y is already there. So y sub c is the average. And then, of course, your y there, your y here is the y upper, y lower. Okay? And then, okay, if you will expand this one again, there will be a 1 half, so factored. That will be y upper squared minus y lower squared. Okay, what is our y upper again? 3x squared at 1. Y lower squared is x squared. Squared at 1 is x raised to 4. So square 3x is 3x squared and 9x squared. Square x squared is x4. So integrate that one. Limit is still 0 to 3. That will be power rule 9x3 over 3, or that will be simplified as 3x3 minus x raised to 5 over 5. Upper limit 3 substitute is 162 over 5. Lower limit is 0, so substitute is 0. So multiplied by 1 half, that is 81 over 5. Divided by the total area, 9 halves, 18 over 5, or that is 3.6. So still the same. The value is still the same using a vertical and horizontal strip. It's up to you to figure out which one is simpler, but as I've said, look at the equation. If y is separated, then make use of a vertical strip so that your area is y times dx. Okay? If your equations x is separated, or separating x is simpler than separating y, then the better here choice is to use horizontal strip, since the area of a horizontal strip is x times dy. Okay, so that's it. So this will be your activity. Okay, so let's review some concepts. Okay, so both horizontal and vertical elements can be used in determining centroids of plane area. Just like getting area, you can use horizontal and vertical. And then, if possible, choose the element with single integration to have a shorter solution and simpler integration. So again, as I've said, you can choose that one by looking at the type of the equation. And actually, you can decide on that. You can actually know that one by merely looking based on experience. So if you will master doing this one, you can actually know which one is better, horizontal or vertical, by merely looking at the problem. Again, that is just a matter of practice. Okay, so that's it, getting a centroid of area. So thank you very much for watching. So if you have any question, you can comment below, or we will discuss that next meeting. So thank you very much.